Okay, everyone, please turn to page 247 in your book. This Solve and Discuss. It says, Nancy walked 4 blocks to Maria's house. Together they continue the walk. Nancy's and Maria's walk can be described with the equation n equals m plus 4, where n is the number of blocks Nancy walks and m is the number of blocks Maria walks. Describe how the equation, data, table, and graph reflect Maria and Maria's walk. So if we go to the table, which I hope is presented for you here, we can see that each value of n, right, well, let's scroll down first, right? So the n is our number of blocks walked, is the y on the y coordinate. The number of blocks Maria walks is on the m coordinate. So since Nancy already started walking first, all right, we could say that, let's scroll down here, each value of n is 4 more than m. Oops. Okay. All right. And then we could also state, another way of saying this is that each y coordinate is 4 more than the x coordinate. Okay, that's because Nancy already started walking first, so she already has 4 more blocks on Maria, because Nancy started walking earlier. Okay, so keep that in mind. This is a graph way of showing it. Also, okay, everyone, let's turn over to page 248 for example 1. Follow along as I read. How can you analyze the relationship between dependent and independent variables using tables, graphs, and equations? The Booster Club members want to raise $50 to donate to a local charity. They buy pom-poms for 55 cents each. How many pom-poms do they need to sell to reach their fundraiser goal? Which is the most useful quantity to calculate? So to begin by solving, we have to figure out which one would be the best. The number of pom-poms that cost $50, the money raised from selling 1 pom-pom, the money raised from selling 50 pom-poms. So what we need to do is see the number of pom-poms that cost $50. So let's see what our best choice is here. So that's not going to work. So the money raised from selling 50 pom-poms, all right? And then money raised from selling 1 pom-pom will be our best bet. All right, begin by calculating the money raised from each sale of a pom-pom. The sale price of a pom-pom is $1, right? And the cost of a pom-pom is 55 cents. We have to figure out what we're gonna, the difference is. So we're gonna make 45-cent profit off of that. Now, let's identify the variables. This is the part that's tricky. Let n represent the independent variable, which is the number of pom-poms sold, because that can't change. Let the r represent the dependent variables, which is the amount of money that we need to raise. Now, how can you use a table, graph, and equation to analyze the relationship between independent and dependent variables? Well, let's take a look. So we're going to make a table first. For example, if 10 poms are sold, or n equals 10, then the amount of money raised 10 times 45 cents is $4.50. If n equals 50, then r equals 50 times 45 cents, that's $22.50. And then if n equals 110, then r equals $49.50. So we still haven't got to our goal yet. All right, so the amount raised depends on the number of pom-poms sold. All right, now we're going to graph this. The points are at the coordinates 10 and 450. Okay, so we can see that it's a linear line, it's straight, it's a straight line. So in order to make that $50, now we're ready to write an equation that describes the relationship. So the number of pom-poms sold, n, right? And what we're going to put in there is 45 cents. Okay, so let's take a look. All right, so there's your equation and there's your graph. So let's take a look at the next one. All right, so this is where it might get a little tricky. So it says the Booster Club now raises 41 cents for each pom-pom. Complete the graph and table shown. All right, so write and solve an equation to find how many pom-poms we would need. So what we're going to do is we can write, let's see if I can do this here. We'll write R equals 41 cents times N. All right, we're just going to write it like that. All right, so that's for the first part. All right, and then if we see, we have our graph here. All right, and then over here we're going to have 50 times 20, 50. Over here, what we're going to put in is $61.50. All right, we're just doing 41 cents times 150, which will get us $61.50. Okay, that should be enough. Let's see here. Oops. All right, so there we have our graph. What the heck? All right, so we should have, well, I'm not going to go back, but you should have the $61.50 for your part. And then for the graph, there we go. Let's do this again. All right, so we have that. There's our lines plotted. So we have this right over the halfway mark, and we have a straight line which we could easily draw out if it lets us. All right, so make sure you have that written in, and it's a little more. Okay, everyone, let's look at example 2 now. The temperature was 6 degrees Celsius at 8 a.m. and increased 2 degrees Celsius each hour for 6 hours one spring day. What was the temperature after 6 hours? Right, so we'll make a table to relate the numbers of hours N to the temperature T. The starting temperature is 6 degrees Celsius. So we're not starting at 0, we're starting at 6. So when N equals 0, T equals 6. Then the temperature increases 2 degrees every hour, or 4 degrees every 2 hours. The temperature was 18 degrees Celsius after 6 hours. Notice the temperature T depends on the number of hours passed, which is N. And then we graph the ordered pairs. Another way to represent the problem is to graph ordered pairs on the coordinate plane. Plot the number of hours N on the x-axis. Time is usually on the x-axis. Plot the temperature in degrees Celsius T on the y-axis. Show the starting temperature of 6 degrees Celsius by plotting a point at the coordinate 0, 6. And the temperature increases 2 degrees Celsius each hour. So you should go up to, over 1 and up 2. The x coordinate increases by 1 hour and the y coordinate increases by 2. Alright, so it should be consistent. There you go. Alright, each point in the graph corresponds to one of the rows of the table. We can extend the line. The dashed segments show that the point with coordinates 6, 18 is a point on the line. The temperature was 18 degrees Celsius after 6 hours. Alright, so let's look at the triad. Alright, so it says that we have if y or x equals 3, what we're going to use here, we'll use this first. X equals, the company makes decorations for pens. All the supplies cost $5, and the company plans to sell the decorations for $2 a piece. Analyze the relationship between the number of decorations sold and the profit by completing the table, using the table and then the graph to write and to solve an equation. So, what we can type in here, all right, we're going to have 2x, all right, make sure I'm in the right spot, 2x minus 5, okay, minus 5, okay, so that's what we have here. And then for our coordinates, we have 3. Well, we're going to have 3, and then the next one's going to be 1, right? And then for the next one, we'll have 4, and then that's going to be, oops, let's see. So we have 3, 1, and then we're going to have 4, 3, and then let's see if we can do any other ones. All right, so we still have that same equation. All right, here's our graph. All right, and then we can see that at